In this video, we're going to discuss analytical consequence and the Anacon mechanism in Fitch. Let's turn to that. So oftentimes we can make valid inferences merely on the basis of the words that are employed in a statement, merely on the basis of the concepts that are being used. And that's how analytical consequence works. So take this first sentence, for instance. Bob is a bachelor. If I understand the meaning of bachelor, I'll understand that it means unmarried male. So if I know that it's true that Bob is a bachelor, then by the very meaning of bachelor, I know it's got to be true that Bob is unmarried. And I know it's true that Bob is a male. Or using a different sentence, Sarah is the mother of Sue. If I understand what mother means, then I know that Sue must be the child of Sarah. All right, so that's what we mean by analytical consequence. We're able to see that there's a logical consequence. We're able to see that one statement does in fact follow from another statement merely by the meaning of the words that are involved. All right, so let's talk about Anacon now. Anacon is a mechanism in the Fitch computer program that works kind of like a rule does in Fitch system. In that, Anacon allows us to draw valid inferences. The way that allows us to draw valid inferences is by using an analytical consequence on the predicates in question, but it's limited to the predicates in the block language. That's the only predicates that it's able to analyze correctly, with the exception of the between predicate and the adjoins predicate. It can't handle those. Those are too complex for it. So one example of Anacon then might be moving from this statement, A is to the right of B, to this statement. B is to the left of A. If you understand the meaning of the right of predicate in Tarski's world, in block language, then you'll know that if A is to the right of B, it's going to have to be the case that B is to the left of A. So Anacon, by applying the rule Anacon to this step, by citing that step, then you can make this inference. So that's one example. So let's actually turn to the Fitch computer program and see some of the things that we can do with Anacon. All right, so let's start by using the example we were just talking about. I was saying that based on the meaning of the right of predicate in the block languages, if we know that A is to the right of B, then it's got to be true that B is to the left of A. And the Anacon mechanism is able to analyze the meaning of the block language predicates with the exception of the between predicate and the adjoins predicate. So the Anacon mechanism should be able to move from the truth of one, that because one is true, that two must be true as well. And we can check this out. We come to the rule drop-down menu, come to the con, and find Ana, and then we need to cite what we're relying on to know that 2 is true. In this case, that would be step 1, so I highlighted it. And we check it out, and indeed, it is a good inference. Now, if I was to try to say that A is to the left of B, we'll see that come out as an X because that doesn't follow from 1. Let's try a different example. All right, in this example, premise 1 says that A is to the front of B. Premise 2 says that B is to the front of C. Well, I know that based on the meaning of front of, if A is in front of B and B is in front of C, A will have to be in front of C. But I also know that if A is in front of C, C has to be to the back of A. And all of those inferences are merely a matter of the meaning of the predicates in question. So Anacon should be able to detect, as it were, that 3 follows from 1 and 2 being true. And in fact, it does. All right, there's one last thing I want to illustrate before concluding this video, and that's that Anacon is not only sensitive to the meaning of the predicates in block language, with the exception of the between predicate and the adjoins predicate, but it's also sensitive to the meaning of our quantifiers and the meaning of our logical connectives. Now, we'll discuss quantifiers and we'll discuss logical connectives later on in the course, but I just want to go ahead and give you a sense about how it's sensitive to those, how it understands the meaning, and can still derive valid inferences as a result. So if we look at step 1 here, it involves what we call the universal quantifier. And what it says, what this sentence says, is that everything is a cube. Premise 2 says, if B is a cube, then D is smaller than F. So what I've highlighted in blue here, or what do we have right here, that is the symbol for a material conditional. So if everything's a cube, then I know from 1 that B is going to have to be a cube. And since 2 says that if B is a cube, then D is smaller than F, then I know from 1 and 2 being true that it really is going to have to be the case that D is smaller than F. But if D is smaller than F, then by the meaning of smaller and larger than, it'll have to be the case that F is larger than D. So our Anacon will only be able to show that 3 is in fact an inference from 1 and 2 if Anacon is sensitive to the meaning of our quantifier and to this logical connective. And we see that in fact it is. Of course, it also needs to be sensitive to the block language predicate smaller than and the block language predicate larger than. So what that means is that Anacon is an extraordinarily powerful mechanism in the Fitch computer program. And for that reason, you'll note that in many of the exercises that you do, there'll be constraints or limitations for how it is that you can use Anacon for that exercise. And that finishes this video on analytical consequence and Anacon. Thanks for watching.